What's going on, YouTube? This is IPSEC, and we're doing another Sherlock from Hack the Box, which are defensive challenges. This time we're doing the first in the Crown Jewel series. And if we look at the Sherlock scenario, it tells us the Forella domain controller is under attack. They believe the domain administrator account was compromised, and the threat actor dumped the NTDS.DIT database on the domain controller, which is very bad news. The NTDS.DIT database is the heart of Active Directory. It contains all the NTLM hashes of all the users, and not only their current passwords, but their previous passwords as well. And they're all hashed with a very poor hashing algorithm called NTLM, which is just MD4. So it's unsalted, no key length extension, very easy to crack, but that's not the worst of it, right? The worst thing is the KOBTGT hash, which is the signing key for Kerberos, is also contained in this database. If the attacker gets it, they're able to impersonate any user on the domain that they want through the golden ticket attack. And that is been a thing since like 2014. And Microsoft's original recommendation, it may still be the recommendation, I haven't checked lately, is if that key ever gets compromised, to burn the domain down to the ground and rebuild because it's that bad. Because in order to invalidate the KBTGT signing key, you have to change the hash twice, and you can't do it in quick succession because it has to replicate throughout the domain. So if the attacker queries that KBTGT hash again when you change it once, then they get the updated copy and they're just like infinitely persisting on the domain. It's very hard to get them off. But enough of that. Let's keep going on with the scenario. They believe the attacker used VSSAdmin to download that database, which is volume shadow copy. I forget exactly what the S maybe is. Maybe it's like volume shadow service admin. Essentially, this allows you to create backups on your hard drive. And a lot of attackers will use VSSAdmin to create a backup of the C drive and then grab NTDS.DIT out of the backup, because normally there's a protection put in place so you can't just read NTDS.DIT, but if it's in a backup file, then you can read it, right? So it looks like that is the attack. Before we go into the actual files, I also like looking at the Sherlock info page to see if there's anything else. It looks like we'll just learn how to detect NTDS.DIT dumping through event logs and the MFT, which is master file table. So let's go ahead and look at the data we're given. On my box, I've already unzipped the data. We have it in the artifacts directory, and they give us a bunch of event logs and then also give us the MFT file table. So we'll get into this MFT thing a little bit later. Let's just start off with all these event logs. And the first thing I like always doing is using chainsaw to parse these. So what I'm going to do is go opt chainsaw, then chainsaw, because this is where I have it stored. Then we're going to do a hunt operation. I'll grab all these event logs, so star EVTX, and then we'll give it the sigma rule, so opt chainsaw sigma, and then the mapping is going to be opt chainsaw, well, not chisel, chainsaw mappings. And then I always do the logs. Let's see, event logs all. There we go. Oh, there's also MFT logs all. I wonder if that's the MFT file. I don't know exactly what that mapping is, but if we run this, it's going to load the detection and give us the result. I'm going to make my font a little bit smaller because this table is a pain to read on large font. And we can see the detection is scheduled task deletion, which doesn't really tell us all that much. And if we look at the event data, the first thing I notice is this ends in 500 for the SID. So I know this is going to be an administrator user. RID 500 accounts are just the local admin, right? And then we got the task name, create, explore, shell, unelevated tasks, which if you're like experienced defender, I'm guessing you'll know this is probably going to be a false positive, but I did not know this at the time. So my next step was I searched the process ID to try to get more information about this. So let's go back to our chainsaw command. I can make this font bigger, and we're going to go back here. We can delete all of this. And then I'm going to do a search, and then I'm just going to type that process PID, which was, what was it like, where is it? Maybe I have to make this font, change it again real quick. Hold on, 6264. So we'll search this, and then we can look at all the results. because it was only 3. This first result, it's coming from the NTFS operational event log. So I'm going to ignore this. I'm guessing that number, like the 6 whatever, just existed within one of these numbers, so it doesn't really matter to us. It's just like a false hit. The next one is Microsoft Windows Security Auditing. So if we look at this, let's see the event data. We have the client process PID, which looks like it's the same. We see it's the administrator user. They have this task. I don't know exactly what this is saying. I guess we could Google this event log. So if we Google like event ID 4699, actually, let's just use ChatGPT. What is the Windows security event ID of 4699 and see what it says. A scheduled task was deleted is what 4699 is. So it's just telling us this task was deleted. Okay. And then this final one, we have the task content, which is just straight XML data. And looking at it, we see it just executed C:\Windows Explorer.exe. And the argument was no UAC check. So that was somewhat interesting. I went ahead and just Googled this create Explorer on an unelevated task. And then I saw a bunch of just normal things querying it. So I deemed this was a false positive. And this hunt operation didn't really give us that much data. So before we get into the actual logs of everything, I want to go and look at like what data we do have. So I'm going to do a dump command. So we're going to do chainsaw dump on all our event logs, give it JSON, and then I'm going to dump it in, I'm just going to call it events.json. And then now we can go ahead and query this. So let's go cd ... I'm going to cat events.json. We have all the events. And the first object is a list. And I always just get rid of that right away. The reason why is if I do a jq.-c, if you have that list, everything is going to go on one line. I just highlighted multiple events. I hate when that happens because it's going to mess up with like greps later on. So I'm going to do that list item to get rid of it. So now when I just double click, every event is just on one line, which is going to make it play much better with grep. So that's why I always hype on making sure the first query doesn't have a list item. So now with that, we want to just look at all the event IDs. And each Windows event log is going to be, they may have the same event ID with a different name. So I want to make sure all my event logs, when I do my query to get like event ID to name, I also make sure that's taking into account the event log name, and that's going to be the channel. So what I'm going to do is search for each channel first. So that's going to be event system channel. So we can do .event here, and then I'm going to pipe. And the reason why I'm doing this is because every event has a event ID, which is going to be like the data in the event. And then you have this system, which is going to be information about the event. That's the only thing in this event object. So if I just put that over here, I don't have to type .event 100 times. So that's why I'm doing that. Because if I now do this, that event's gone and we just have a bunch of objects with system and event ID. And that's just how I like it. So we have that .event, and then we want to do a select. So we want to do select, and then was it system.channel? Was it channel name or just channel? Let's see. System channel, okay, is equal to system. I don't know if there was capital or not. It's probably going to be a capital S. So now this just got me every system event log. So now what I can do is just do a .system and then event ID. Let's kill that one quote. And then we have a list of all the events. So I'm going to do a sort, and then we can do a unique -c. And then let's do a awk print, then 2:1. Okay, so now we have a list of every single event and how many times it occurred in our log. So what I want to do now is copy this over to my clipboard. So I'm going to do xclip-selection. I think it's primary, or maybe it's going to be clipboard. I'm just going to do them both to make sure it's in my clipboard. And I'm going to go back to ChatGPT and then say, let's see, I have a list of event IDs and then a colon and the number of times they occurred from the Windows system event log. Can you add a third parameter stating the event name based upon the ID? Let's see if ChatGPT helps us out here. And it looks like it is. It's kind of weird how it's saying 1 occurrence, 2 occurrence, whatever, but I'm happy with this. We have event ID 136. This is just going to give us a lot of information about what our log contains. And then we can copy this to our disk. So we have like login, so we know what user logged in, a network connection, what time the system booted up. Oh, volume copy service operation, 1 occurrence. We know the NTDS.DIT happened around this time through VSS. So this is probably going to be a really good event to have. We have a disk error, volume information change. That could be more shadow copying. Unmounting a volume could be a shadow copy. Like there's a bunch of just good information we have here. And I don't know if we need this information. It's just something I like always having. So I'm going to call this, we'll call it system.text, I guess. Paste this. And then I'm going to go ahead and get rid of event ID space. Okay. And that's fine. Then let's do this for the other things. So we had the system security is another log we have. So can you do the same with security? Paste. Oh, that did not work. Wrong clipboard, I guess. Clipboard. There we go. Paste. And we're going to see all these logs. So the system log, this is going to just tell us like system things like service starting, stopping, the volume shadow copy, errors. Security is going to tell us like logins, audit logs, new processes, token stuff, things like that. And then the last log we had was related to the like NTFS file system, which that's a new log for me. I've never really viewed that before this, so I'm kind of excited to see what logs are in that. So I'm going to call this one security.text. Then we can hopefully paste it. Oh God, paste it a few times. There we go. Let's get rid of event ID space. I screwed something up, but that's quick to fix. Okay. So let's just call this next one, or last one, going to be NTFS. And then we should figure out exactly what that log is, the channel. So let's just do a select on system channel. Delete everything here. Sort-U. And it's going to be Microsoft Windows NTFS operational. Okay. Delete that. Paste that. And the same with NTFS operational log. That looks fine. I was like, is that the security log or not? But nope, this definitely looks right. And we get all the data here. So this is just going to help us answer the questions, because if it asks for a task, we can go look at the like type of information in our log and then figure out what event ID we want to filter on to see this data. We may not use this at all, but it's just something I always like having, right? It's better to have it than not have it, in my opinion. And I don't know why we have that tab there. So we can delete this. Okay. Then %s event ID. There we go. Okay. So now we have our logs kind of analyzed. So let's go ahead and go back to the questions and see what it wants us to do. So the first one, attackers can abuse the VSS admin utility to create volume shadow snapshots and then extract sensitive files like NTDS.DIT to bypass security mechanisms. Identify the time when volume shadow copy service entered a running state. So we could, just based upon what logs we have or the data we just gathered, go to like the system log, because this is probably going to be where services start and stop, and then figure out what event ID this would be related to, right? I'm guessing it's going to have service in the name. So maybe if I do grep-i service on system, let's see, we have failed to start, change state, type of service changed. The event log service was started, so that's probably not it. Maybe change state. So 7036 we could look at. If we look at security log, do we have anything here? So grep-i service. Kerberos service ticket was requested, so nope, nothing there. So I'm going to guess 7036. Let's try looking at that event. So let's cat the JSON. Then we can go JQ dot, then dot event, pipe it over to a select. Then we do dot system event ID is equal to what I keep forgetting that number I keep saying. Let's see. Scheduled task was disabled, created. System.text 7036. Okay. So we have right now param1 WMI performance adapter state is stopped. So param2 looks like it's going to be the state and param1 is going to be the name. So we can just grab event data dot param1, then sort -u grep-i on volume. And there is a time when volume shadow copy is param1. So let's now also do a select, then event data dot param1 is equal to that. And there we go. We have volume shadow copy param is running, and we want the time. So it's probably going to be this. Probably up to the second. Wrong answer. Let's see, is there 2 events here? Just one? Oh, I think it doesn't want the T. Year, month, day, space. Yeah, it did not want that T. There we go. That's successful. Another way you could do this, I'm going to show like ways to cheese the answers, right? So we just did it the very like surgical way, looking at the data we have in the log, grepping, and selecting and searching. But you could just grab this data, right? And then do the -c like I had said before. And now we can just grep-i shadow and then JQ dot. And the very latest log is this running, which is the time. You could also like grep-i run, and it'll probably only give you 1 event here. We get 2 events. So let's do a JQ dot to look at them. Again, this is going to be the volume shadow copy running. And then this one is something about the volume shadow copy. This is going to the NTFS log. I'm guessing run just exists here. Yeah, runs cached. So that's why it's hitting, because runs is a key here. But this is probably related to it, because the device name, device hard disk volume shadow copy 1, this is the name that a volume shadow copy would be given. So if they're copying NTDS.DIT, this is going to be the hard drive name, right? So this is probably going to be important later on, but that's a good way to just grep through logs if you don't know like what event you're looking for. If you just want to like explore your data in a very quick way, that's a good way to do it. Okay, next question. When a volume shadow snapshot is created, the volume shadow copy service validates the privileges using the machine account and enumerates user groups. Find the 2 user groups the volume shadow copy process queries and the machine account that did it. Okay, so we want to look for like a service querying groups. Let's go ahead and do this again like the surgical way. So I'm going to cat the security.txt because this is kind of a security thing. Enumerating groups, probably security related, right? So looking at this, let's see. We have 4799 and account was enumerated. Looking through all these, I think that's going to be like the only thing that could be. So let's go back to our JQ command where we selected things. And I'm going to just look for event ID 4799. And then we have event data, target username administrators, subject username, this would be who queried it, is DC01. And then we have the process name of what did it. So what I'm going to do now is a select on event data dot process or caller process name. Caller process name. And we see a few processes. We have DFS, which forget exactly what this is. Probably like the directory service, like Active Directory service, I believe, like replicating to other domains, I want to say. Distributed file system replication. That's what it is. So it's probably the AD service like saying, hey, this user account changed. Let me replicate this change to another AD server is my guess what that is. And then we have SVC host, which is just a service. LSAS, this is going to be like a bunch of like where all the credentials are stored. Like if you run mimikatz logon passwords, it pulls the passwords out of the LSAS process memory. Another service, more replication service, but VSSVC, this is going to be the volume shadow copy stuff. I don't know exactly what VSSVC stands for. I guess like volume shadow service volume copy, maybe? Let's see, does it say? Volume, let's see. ChatGPT may know. What does this stand for? Volume shadow copy service. That's not the order. Okay. It's related to volume shadow copies. That's all that's important, right? So now we can search for this as the caller process. So let's do a select event data caller process name is equal to this. And we have to close out our select. There we go. And then I'm going to grab event data. And let's see, we just want to get the groups that it queried. So I'm going to select target user name, sort-u, and it's the administrators and backup operators. These are the 2 usernames it enumerates. So we can go back to the question, say administrators, backup operators, and then the machine account that did it, that's going to be the subject username, which is DC01 $. So we can put that in. And it did not like that. Let's see. Administrators, backup operators. Is there no space? let's look at what the tooltip said. We had a comma, then a space. Maybe that's it. We add a space after each comma. Okay, that's it. Man, that was annoying. Let's go to the next. Identify the process ID in decimal of the volume shadow copy service process. If we go back to this log, we do have that, right? That is going to be this PID, the caller process ID. This is in hex, but we can quickly convert this to decimal in Python. So if we just do Python 3, put in the hex, it's 4496. Let's try this, 4496, hit enter, and there we go. Okay, find the assigned volume ID GUID to the shadow copy snapshot when it was mounted. So this is going to be one I cheese. We could, again, probably go into the NTDS.TIT and then guess what it is, but I couldn't make a good logical guess. Probably one of these that has a lot of occurrences. Maybe the file system disk is corrupted, unusable. Like, I don't see one that just says like volume shadow copy mounted is what I was looking for. So we could go through and look at each of these events, but when in doubt, I like cheesing and then just like, once I find the answer, going back and discovering what it was, right? So I'm going to delete all this data. We'll add that -C again. So every event is on its own line. And I'm going to do an egrep. So this is going to allow me to do good regular expressions. And it's asking for GUID. And this is 8 characters, -4 characters, -4 characters, -4 characters, -12 characters. So I'm going to write a regular expression. We'll make this case insensitive. I'm going to say 8 characters, dash A to Z, 0 to 9. We'll do 4 characters. And if I have to keep going, I will. But if I don't get a lot of collisions here, that's fine. Let's see, grep-I. Let's see, what do we, oh, we put the -C in this single quote, and that's not it. So right off the bat, we kind of screwed up. Looking at it, we have a lot of hits because there's a GUID in the system. We just want to look at event data. So I'm going to go over here to the query, and we're going to put .event data. So we're going to have our JQ filtered down here. So the -C only shows us event data. If I put a comment here, we can show this better, right? There's not much JSON on each of these lines because, again, it's just the event data. So now we're going to grep when the event data has a GUID in it. And right off the bat, let's see, we have this, which I don't know. Let's see, drive name. Let's see, why did this match? Oh, we got login GUID. I'm getting a lot more GUIDs than I actually expected. I wonder if I don't want that -I. Maybe I got lucky before. Let's see. We can do a GUID and also contains the word shadow. There we go. That looks better. So now we're looking for all the logs that contain the word shadow and have a GUID, and we get a few, right? So we have this volume correlation ID, and that looks like it is the only GUID we have, other than these all zeros, which is just blank, right? So I'm guessing the answer is going to be that GUID. For good measure, we can see if there's any unique ones here. So we can just select that. And then looking at that, that's all the same. So let's put this GUID in. So I'm going to copy, paste, submit. It probably wants it in brackets. There we go. And like I said, I want to go backwards and understand like where this occurred. So let's now go back. I'm going to get rid of this. Let's just do cat events like this. Okay. And we can say select, then dot event data, dot volume correlation ID, if I spelled that correctly, is going to be equal to our GUID. So let's copy this. Paste that. We got to close the single quote. Awesome. And now let's just get all the event IDs. So I'm going to now query dot system event ID. We have 4, 9, 10, 300, and 303. So I'm going to do a for I in this file. Do. If I just echo I now, we just have each of these, right? And the whole reason I did that is because before we created this, these TXT files. These are going to be in the NTFS log. And if I look at NTFS.text, I have event ID colon. So I'm just going to replace this echo I with grep. The line begins with I, then has a colon on NTFS.text. And then we have all the events that contain that GUID. File system structure on disk is corrupt and unusable, meta corruption, integrity check. This is probably going to be the one I should have checked, because when you mount a disk, it probably does a file system integrity check. So it makes sense for the GUID to be there. We have disk operation failure, disk read error occurred. I wanted this occurred because like a permission. I don't know why like all these failures occurred for a shadow copy. I don't know if that's normal. But this is going to be the one I probably should have just gravitated towards when looking at event logs and filtering, right? We could just look at event log 10. So let's go back to our select statement and say system.event ID is equal to 10. We may have to also filter on the channel. It's not clear to me if, what was I going to say? 10 exists in system and security log. Oh, we don't want that for. Huh. System event ID. I expected to get rid. Oh, we have it in quotes. There we go. So, nope. There we go. This is good. That's what we expected. NTFS, shadow copy 1. I wonder if there's other device names. We can do event data dot device name. Yep. So we have different GUIDs for other things. So like it, for every volume, it ran the system integrity check. And I'm guessing those GUIDs are going to be different. Right. That's going to be 44F9. Yep, that's a completely, oh, that's a system. Completely different GUID because that's the volume 4 of hard disk. So that is that. So now we're going into task 5, identify the full path of the dumped NTDS.DIT database on disk. So let's just now go back to events. And I don't know what event log this would be in. So again, I just go back to cheesing it and we can grep-i NTDS.DIT and there's no results. So I'm thinking we have to go into the master file table from this point. So if we go into the artifacts C, we have this MFT file, and Chainsaw I think has a bug, or maybe I don't know how to type the $ in Chainsaw, like to get it parsed correctly. But if we do dump on, let's see, like $MFT like this, it loads the artifact and doesn't do anything. We try to escape it, doesn't do anything. I renamed this. So if we, let's see, rename it, and I'm just going to call it mft.bin. So now when I run Chainsaw on this MFT, it dumps a bunch of data. So I'm going to do --JSON, and then I'm going to put this up to directories, and we'll call it mft.json. Let's direct the file there. And it's going to take a little bit to dump. Doesn't take too long. I think that file is probably going to be like 80 megs. Let's see how big this is. 87 megs. Okay. And this is going to contain a record of all the files on disk. So if we cat this, pipe it over to JQ, we can just see tons and tons of files, like the full path. This is something in the Windows directory. So all I want to do is a JQ. Let's tail-1 real quick. I may have wanted to do a head-1. Maybe that would have been quicker. So it is in a list. So I'm going to do JQ open, close like that. And then -C. And that's going to put everything on one line. I can grep-I NTDS.DIT. And then we can do a JQ dot. And this is going to show me all the lines that contain NTDS.DIT. And we have the full path, Windows System 32 NTDS.DIT, which looks like it's probably going to be the default location of where this is. But we have another one right here, Users Administrator Documents Backup, and contains this. So this is probably the file we want, right? Because it said full path of the dumped NTDS.database on disk. And it probably wants these slashes to be correct. So like this, C:\users administrator submit. There we go. So when was the newly dumped NTDS.DIT created? And we can just look at the timestamps. So last modified, last access, info created. We can copy this. And then it does not like that T. Submit. Okay. And the final question is, a registry hive was also dumped alongside the NTDS database. Which registry hive was dumped and what is the file size in bytes? So we see the folder is backup sync DC. So let's go back to our query and change our grep to just be backup sync DC and show all the files here. So we can see NTDS.DIT. We see a shortcut file because it ends in .lnk. We also see system in all caps. This is probably going to be the system registry file. And then this is going to be the folder because there's no file there. So it's probably going to be system. And then the size in bytes. So file size. I hope this is bytes. But that. Wrong answer. Let's see. I don't know what like unit of measurement this is. It may want a comma, a space after that comma. There we go. That's what it was. It was system, comma, space. And that's going to conclude the Sherlock. So hope you guys enjoyed the video. Take care, and I will see you all next time.